Okay, the first thing I'm going to do participation. Let's go for New York Times. Uh, let's look at CBS, the different news media. CBS. Allow. Wait a minute, this is not CBS. I need to go to CBS News. Oh, it's Trump? No, I don't like Trump. All right, I. Just one letter. That's easier. I, just I. All right. So let me go over here. Max. Is EE1520 server. CPP. Yeah, sometimes the secret is very simple. Here. Yeah, I'm getting shorter and shorter. Okay, just one letter I. Oh, I have to turn on let me turn on the NG Rock. Okay, and I have already compiled. Okay, you should be able to get to this. Let me see. Okay, I got some of yours. That's great. Okay. Um, I'm going to continue to work on the RPC, remote procedure call. It's my experience that understanding remote procedure call is very valuable for programming in today, or sometimes we call web programming or internet programming. I want to just recap about what we did last time, and then we will move on to CPP08 and CPP09. I hope to finish CPP09 by the end of today. That's a if. Okay, so I just want to show you a demo. This is what we did last time. And it's based on the specification file. This you can think about remote procedure call is like an API. It's like you have a one program you want to access to the program served by the other program. That's why we have a client server. The client is the one who initiate the request for getting the service, and where server is the one who receive this request. So when you make a call, usually the caller and the callee were both in the same program, but under RPC, which stands for remote procedure call, we separate the client and the servers. The client is likely to be on your local device, and the server is running on the other machine, such as data center or such as Facebook or Google. Okay. All right. So let's take a look at this. I'm just want to do a demo very quickly, but I want to move this bar somewhere else. It won't interfere with my lecture. Okay, so if I create two windows, so first one, you have to run server first. If you don't run server first, you're going to get the cannot, the CURL error 007 that it cannot connect to the server. So over here, the server is already up. So I just say WR client. And when I do this client, you can see this is a remote print. Now it's actually being printing on the other machine. So it's supposed to, if I put both of them on the same program, then the print should be on the client side, but it's actually on the server side. Okay, so I'm going to write down my lecture for this, note.txt. So I'm going to recap what we did last time. So this is about remote procedure call, RPC. Okay, so remote procedure call, the first thing you need to specify, and particularly in this lecture, we're going to talk about probably the most commonly used RPC is called JSON RPC. So which means that the mechanism to allow client server communicate together are all based on the JSON specification. And alternatively, the other one, which is also very popular, is called gRPC. So gRPC is Google RPC. So the difference between JSON RPC and Google RPC is JSON RPC, everything, including the communication, are going to be encoded in the JSON format. So this is very readable. By the way, JSON, the best thing about JSON is very readable. You can easily see what's going on. For example, if you talk about a popular service such as Facebook or Twitter, they're all based on JSON. They're all based on JSON RPC. I still remember Elon Musk, when he first acquired Twitter, he basically talked about the performance problem with performance issue with Twitter. And if you see his message, he is basically saying that the JSON RPC is actually getting some kind of overhead. Okay, so this is a very popular, it's very easily readable. But gRPC is not following JSON because Google would like to get extra performance. So they use some kind of compact representation about the information that you used to encode in JSON, and such that I save things like a network bandwidth and a few other things related to the performance. But conceptually, JSON RPC and gRPC, they're trying to accomplish the same thing. The only difference is just the representation. Okay, so we're going to talk about JSON RPC in this class. If you're interested, for example, if you work for Google, maybe in the future, then you can extend your learning about JSON RPC into Google RPC. I just want to tell you that this is a good story I heard many times while I was an instructor at UC Davis. The student usually, when they learn JSON RPC, they don't know why they need to learn that until they got a intern, summer intern or whatever intern at the Silicon Valley. When they ask them questions, then they realize how important this concept is. Okay, so if you want to work for this kind of web-based company or services, that this concept will easily come up. Okay, so I want you to kind of learn it, know how to programming. At least you can show some demo. If you bring a computer to the interview, you can easily show a demo about JSON RPC. So the first thing is I have to specify the call interface, call or the function or procedure interface. Okay, this is the first thing you need to do. And in this example, we use this file. So I'm going to put it here. This is being specified in the WR.JSON. This is a file. If you remember that, this is the program. This is the file, the EC36B WR.JSON. It basically specifies that's one call called remote print. Okay, and you can make much more complicated than this simple example it accomplishes. But usually, my experience with remote procedure call, it won't be too complicated because you don't want to design your remote procedure call to be too complicated. Okay, as well. Okay, the first thing is you have to do this. The second thing you need to learn about JSON RPC related to the makefile. Usually we modify the makefile. Inside the makefile, we have to use a program called JSON RPC stub. So JSON RPC stub will generate two .h file. In this case, it will generate this two file. Let me make sure I understand the name, wrserver.h and wclient.h. So it will automatically generate wrclient.h and wrserver.h. So essentially, the JSON RPC stub, which is a code generator, it will based on the interface that from number one, and it generate two file. Okay, and this two file, it makes sure that the client side and the server side, they're following exactly the same interface. So you can see that you specify in one place, but it generate two code. And they guarantee the definition of these two code are compatible with each other. And that's actually follow. It's a communication. A communication, you have a two party, they must agree. Okay, that's the second part. You need to generate that. Okay, and the third thing is you have to start write the program itself, which is WR, the program, which is the .cpp file. This, you might have two or more. You might have two or more. And you could have as many as you want, but they're all following the interface that's defined by step number one and step number two. So in this example, we have WR client.cpp and WR server.cpp. Okay, in this program, we only have a two program that's actually sharing. And the important thing is that you have to make sure that in order for the client and server to talk to each other, you have to use this micro HTTP setup, which is the important thing is URL. URL plus the port number. URL is essentially, yeah, I would just say URL plus the port number. Let me give you an example as we show in this, yes. If you look at WR client.cpp, this is the line we use to set up the URL and the port number. Okay, this is the line that you basically set up the URL to be HTTP 127.0.0.1, and then the port number is 8309. Okay, and this is on the client side. And on the server side, you will have another line to accept the same port number. The server side, let me just turn it off. Server side, it must be WR server.cpp. It's fairly similar to pretty much every single program you use. So in the server side, I just run this line. This line, HTTP server with a port number. Okay, and these two need to be, so with remote procedure call, it's always pretty much everything you have a client side and the server side, they need to connect. Because we separate them into two different programs, so they have to connect in every perspective. And you can see that the only place they need to be connect here is the port number and not the URL. Why is URL? Because this server, wherever you decide to run this program, that particular machine must have an IP address and must have a web portal for you to come in. And therefore, when you actually set up this, it's enough because when I'm running server, I already got the first part, the URL part. And the only part I need to say is, hey, I'm on this machine. I'm accepting whatever request toward this particular port called 8309. By the way, just to let you know, later you will learn about internet architecture. So this is called, the port number is usually in what we call layer 4. This is called internet. By the way, internet has a 7-layer. Layer 3 is what we call network layer, which is the IP address. And layer 4 is what we call transport layer. And in transport layer, it's how do you decide which program you're going to accept this particular transport connection is based on port number. So the port number is a 16-bit integer. 16 bits. (16-bit) integer. So in other words, there is a limitation on how many different ports that you can have on a single machine, which is 2 to the 16. You can only have 2 to the 16 different program that's accepting incoming connection. Okay, you can run so many programs, but it's only about 2 to the 16 that you can actually have a different program. Okay. All right, so this is the third part that you have to set up the client and the server and just run the program. I do want to say one thing is that, okay, I said there was a 2 or more program. I mean, over here we have a client and the server, but let me actually give you an example that I could have a multiple program. For example, I could have a program called WR Felix. Okay, it's a person. I can have a person, which is a program, and I can have a WR bus 77. I can make the bus 77 in homework 2 a program. I'm not saying you should do this for your homework assignment number 2. Okay, this is just potentially homework assignment number 2 can be easily using remote procedure call. And then I can have a program called WR NCKU hospital. Okay, and then I can have a WR EE1520 student. What's the student's name? I forgot. George, maybe. Okay, I can have a 4 program representing what we have, right? So each of the program, for example, when I get on the bus, I'm actually making a remote procedure call from WR Felix to the server, which is WR bus 77. When the student George get on the bus is again, George make a call to WR bus. So you can actually implement somebody get on the bus by using remote procedure call because I'm a get on the bus. So you have a function called get on the bus. Okay, and then you can implement a function called get off the bus. So for example, when because George is already on the bus, and when the bus arrives, WR NCKU hospital station, then the bus is going to call NCKU hospital station saying that, hey, I'm going to get off the bus, but the argument that get off the bus is this person, George. Okay, you can actually do this to be able to consider a person is both an object and a program, and the station is both a program and the station. And then essentially you can easily implement a distributed implementation of your homework 2. Okay, in fact, I will show you how to do that. Okay, so this is I'm going to upload this particular instruction. So remote procedure call is a very, very useful mechanism for you to implement some more realistic program. Your program is no longer writing a toy that's actually running on a single computer, but instead now you can use all kinds of resources, including the sensor, the station, the intelligent environment around you, and using a program to explore to that. Okay, so this is, once you're familiar with the concept, JSON RPC is going to help you a lot in develop your final project. Okay, so this is really for your final project. All right, So just 3 steps. First, you have to specify. And the second step, you have to modify your makefile. And one of the lines is using the compiler, JSON RPC stub. Okay, so now we have 3 compiler. You have a G++ compiler. First semester, you should learn GCC compiler. And now we learn the third compiler is called JSON RPC stub, which is also reading JSON and generate program. C++ program. And then you write a driver program to utilize, and just make sure you remember this. Whenever you're doing client and server, and you have to include WR client.h and or WR server.h. I don't know if you noticed, I gave you an interesting example that WR bus is both a client and a server. In the scenario I talked to you, when Felix get on the bus, WR Felix is the client, and WR bus 77 is the server. But when Felix get off the bus, then the WR bus 77 is the client, and WR NCKU hospital station is the server. You will see that the role of a client and server can be really flexible. You can have a dual role, single role, depending on your application domain. Okay. All right, I'm going to move on to talk about CPP08, which is a remote object. Any question about remote procedure call up to this point? I mean, the best way to learn about remote procedure call is go through this 3 GitHub repository, CPP07, 08, and 09 under sfelix Wu. And this 3, and then you basically download the program, you type in make. It should work without any issue on your environment, either it's WSL or is Mac, and then you can run it and then try to trace the code. And the code is not big, but that's the best way for you to learn. Okay. Any question? Okay, I'm going to CPP08 right now. CPP08 is called remote object. So again, we have to look at 3 things. The first thing, we should look at the JSON file, which is ECF36B ro.json. This is a specification. Let's take a look what it is. And I already forgot what it is, to be honest with you. Okay, so this one has multiple functions. And okay, the difference between CPP07 and 08 is that CPP07, I'm just making a function call. I'm actually calling the other function that's on the other program. But CPP08, I know I kind of bring the concept of remote procedure call into the context of C++ as a programming language. So in other words, what I'm doing is I know my server has a C++ object. And in this case, this object looks like is going to be a labeled GPS object. That's actually on the server. And then what I can do is I can actually call a member function that's actually on the other program. So usually when you when you access an object, when you make a call, member function is usually on the same program. But now I'm showing you how you can make a member function call across the internet, which is very useful. Okay, so let's take a look at this. So I have the function name is called set GPS label. This is under label gps.cpp or .h. And you can see that I have a function call, I have a class name. I have to give a class name. I have to give an object identifier. Oh, this is important because I need to, because on the server, I might have lots of objects. I might have a bus object 77. I might have a bus object 105. I might have a person Felix. I might have a person George. So I need to know which object I want to make this remote procedure call. What I call a member function. Okay, so I have one function called set GPS label, and the other function is called dump to JSON. So I only have two functions. One is dump to JSON, one is set GPS label. And they're allowing me to communicate with a remote server. So I only have this two function. And again, I make clean to show you. And then I start to make, you see that the first thing it always does is using JSON RPC stub. In this case, it's going to generate RO server.h and RO client.h. Okay. Oh, I'm still recording. That's great. I think I'm in the recording mode, right? Yeah, I'm still in the recording. Okay, that's great. It's clever enough to resume my recording. Okay, great. Okay, I'm still having the RO client and RO server, but because I'm doing remote object, so meaning that I have to have my object-oriented design, which is the label GPS and GPS. You can see that when I generate the server together, I have to include pretty much everything. Let me just explain to you this particular line, okay? Because this line, it covers a lot of things about how to use remote procedure call. So of course, this is a line that link all the object file together for the server side. So you can see that I have a G++ standard C++ 14, and it will generate the output called RO server, and it has three object file, RO server.o, label GPS.o, and GPS.o, because I have to include both the base class object file and the derived class object file. And then you will see that in my make file, I have a minus capital L. So minus capital L basically saying that where do I look for library file? Minus capital L is basically give an extra. You can get multiple minus L. That's no problem because you might put your library file in different location. So on my machine, I put it, because of the Mac, usually if you use the tool called Homebrew, that's a one mechanism for MacBook to install software such as JSON RPC CPP. And therefore, by standard in my environment, is /opt homebrew/lib. If you're a Linux environment, this is probably going to be user local lib, okay? And then if you see minus lowercase l, this means exactly what's the library need to be linked together. Let's look at what library I need to link together. I have to link the JSON CPP. Because I'm using JSON CPP, if you use JSON, you have to use minus L JSON CPP. Okay, but then these few lines are all related to the JSON RPC. Look at here, I include JSON RPC CPP client. I include JSON RPC CPP server. I include minus L micro HTTPD because JSON RPC is based on the standard web protocol, which is HTTPD. And then I have to include another library called JSON RPCCP common, and then find the JSON minus L C URL. Curl C URL is essentially a web browser, but is a web browser in the C++ context. Okay, if you're using Safari or Chrome, of course, you're doing web interaction, but you can easily write a C++ or C program and using C URL. You can actually use your program to access the web and then try to retrieve information. And that's actually very powerful because you can retrieve information directly feed into your program to do processing. Okay, so that's in web programming, this is important. And the other thing I want to tell you is that you see that I'm actually putting both server and client because as I show you, a program could potentially be acting as both client and the server at the same time. That's why it's always good to include everything. And so if the program needs client, it's there. If the program needs server, it's there. Okay, so that's the line. The other thing, You don't need to remember this, by the way. You don't need to remember. I never remember this, by the way. I always just encode it once in my make file. And I just make and assuming it will work. But one day, if I forgot something when I do a make, it will tell, hey, there was a program unresolved. Then I try to see which one I missed using Stack Overflow. Okay, so in programming, I want to tell you, experience is more important than what you need to memorize. Sorry. In programming, you should, as a programmer, you should never try to memorize anything. You should just have some experience. You try to do it, look at the compiler error message, and then decide what you miss. Okay, then you will remind what you have. So that's why I encourage you guys to do more programming instead of trying to memorize this as a concept. Okay, it's more about how many practical experience you have. Okay, it's important for job interview as well later when you want to go out. Okay. All right, so that's the first step. I have this program. Now let's look at the client side. Let's look at the client side again. Let me first run the program. It might be easier to run the program. Let me go to the server. I have to go to CPP, RO server. So now I'm running the program, and then I'm going to run the client program. You see that? It's actually send it over here. Let me just show you what the program does. The program actually receive a call from, oh, wait a minute. I actually got I actually create an object. I create an object called label GPS, and the object ID is 1001. That's the from the server side. I'm looking at the server side, and when you dump the object, dump the JSON of that object, it's a label, is a Costco and Woodland, and the latitude and the longitude and status successful. Okay, that's the dump to object. So I assume on the server I have an object which is a label GPS with the ID 1001. And then I try to set the label, set the GPS label, which I'm making a remote procedure call on the object 1001, and I want to set the label to be teaching and learning complex, which is a different location. So this set GPS label allow me to change the label of the object, and then I try to dump it. The latitude and longitude value are still the same, but the label has been changed from Costco Woodland to teaching and learning complex. Okay, so that's the function it's going to do. So essentially, I can change an object's attribute through remotely by doing this remote procedure call. Okay, so now let's look at the client side. Let's come back to the client side. So let's look at the program. Okay, you will see that the difference between CPP07 and CPP08 is very similar. In fact, go to 09, it's a little bit more complicated because I have to come out a new concept called proxy object. But let's look at the program. The first part is the same, right? I'm just include the standard include file. The only thing I need to change is I need to include the new .h file called RO client. And the reason RO client is because I named that file to be remote object client.cpp, okay? And this part is all standard. So let's take a look at this. This is the same line, right? Is localhost colon 8300. So the port number this time is not 8309. In this program, I choose 8300. So if you look at the server side, it must be 8300. Okay, and then I create my client. And now you can see I make a function call called dump to JSON. Okay, and dump to JSON, remember, according to the RO, ECF36B RO.json, let's look at this. If you remember, I'm actually taking 3 arguments. The one of the argument is called, wait a minute. Why I only have a 3 argument? Oh, sorry. That's the first set. The dump to JSON has 3 arguments: action, class name, and object ID. Okay, that's why you see that I have a dump to JSON as the action, and the class name is label GPS, and the object identifier is 1001. Okay, because there might be more than one label GPS object. So I have to provide what I call object identifier for me to tell which label GPS object I'm actually talking about. Okay. So you can neglect about everything about exceptional handling. I will talk about exceptional handling later. Okay, that's the first call. And the second call, I actually have some of the explanation. I'm going to skip it. I probably already said it. You can take a look. So you see, now I'm actually calling my client set GPS label, which is the second call. I'm using that. And then set GPS label has 4 arguments, still has the action, which is a set GPS label. And I have the class name label GPS. And I have the label is teaching and learning complex. And object identifier is 1001. Okay, I want to actually tell you something about the order. This is a little bit tedious, but you should know about JSON RPC. Let's go back to ECF36B ro.json. Let's take a look at the first one. You see, I have for this call set GPS label. I actually have a 4 argument: action, class name, object ID, and label. But over here, you take a look at the 1, 2, 3, 4. I have also 4 arguments over here and a 4 argument in the ECF36BRO. There is a difference between the top window and the bottom window in terms of this code and correspondence relationship. What's the difference? Have you observed the difference? What's the difference between the top 4 argument and the bottom 4 argument over here? What's the difference? The difference is about their order. Okay, take a look at here. Action, class name, object ID first, and then label. And then over here is action, class name, label first, and then object ID. You see that? The order is different. Okay, so let me tell you that in JSON, when you specify the JSON, by the way, JSON, you can have multiple key value pair. In this case, I have a 4 key value pair. But in JSON, the order about this key value pair is never specified. In other words, when I have a 4 key value pair, you should interpret, if I swap the order about the key value pair, it's the same. From the JSON perspective, they're equivalent. So this 4, no matter how I rotate, their order doesn't matter. It's the same JSON. So JSON doesn't worry about the sequencing or ordering, but they worry about what you have. That's JSON. But in C++, when you actually make a function call, you have to have an order. Okay, you have to have the client call the server, then their order must match with each other. So when the JSON RPC stub, when they generate the code, they have to follow an order. And the order they follow is alphabetic order of the variable name, the key of the key value pair. So in this example, you can see that the 4 key are action, class name, object ID, and label. Okay, and guess what? L, label, should come before object ID because L is actually older in terms of alphabetic order is actually earlier than O, object ID. That's why I actually look at this 4. it generates the code, which is exactly follow the alphabetic order of the key portion about this 4 key value pair in the JSON file. Okay, so that's why the first one is label, the second one is the class name, the third one is the label, and the fourth one is the object identifier. Okay, so in other words, you can switch this in the specification, doesn't matter. Okay, and it will always follow the alphabetic order of the key portion about this key value pair. Does that make sense? Okay, so just a little bit, because if you don't follow the order closely, you will get compiler error. Then don't worry, then you learn from that compiler error. Okay, we always learn from the compiler error to say, oh, that's the way how they actually treat the ordering about the JSON key value pair from JSON to C++. Okay, let's actually go back. Okay, then I make a call, and after I make a call, I do a dump to JSON again on the same object 1001. So what I did in the client side is that I do a dump JSON. Before I set the label, I want to see what's the content, and then I change the label, and then after that, I look at the content using dump to JSON. So whenever you see dump to JSON, it's actually to represent the content of an object in JSON format. Okay, and that's the what's happening here. Okay, so that's the client side. I want to just show you one portion of the client side before I move on. So let's take a look at the code generated. It's very similar to what I showed you earlier, last time. So let's go to our client.h, and again, remember this file is automatically generated. So don't try to modify it, okay? Because makefile will wipe it out if you change it, okay? And over here, if you look at the implementation of set GPS label, again, you see that there's a 4 attribute. This is generated, is follow alphabetic order, action, class name, label, and then object ID. 4 argument passed in as a string. And you can see that it basically say, hey, this is JSON CPP. Action is equal to action. Class name is equal to class name. Label is equal to label. Object ID is equal to object. So it actually encodes 4 argument. The 4 argument you want to pass to the remote into a single JSON called P. And then you just call method with the P. So that's why it's called JSON RPC, because I'm encoding the parameter and its value from the client to the remote. Even though when you look at the client side, it looks like this function has a 4 argument, but internally, it actually encoded into a single JSON, and then they actually send it to remote. Okay, so that's why you have this extra processing about JSON, but you don't need to worry about that. This is supposed to be hidden from you. But I'd like you to know that the internal, so you will know what's going on. Okay? Okay, let's look at the server side. Okay, the server side, I'm actually going to directly go to the function first. See, is again, it's a very simple. The HTTP server is 8300. Okay. Okay. Now, because I want to have an object. Remember, now we're talking about remote object. Then I must have an object that's actually being created at the server side. This is a code at the server side. So you see what I did is I create a object using new label GPS and using this 3 argument bracket initialization, the latitude, longitude, and the initial label is Costco Woodland. Okay, I create this object, and this object is object 1001. Okay, and well, just let you know that I actually I didn't do a static object creation. I'm using dynamic object creation. I want to make sure that this memory, this piece of memory object 1001 is somewhere in the memory, in the heap area, and such that when you exit the function, the object was still there. Okay, so that's the rest of the code is pretty much the same. For example, I will start listening. So by the way, what do you mean by start listening? I should probably tell you a little bit more. Between this line, which is you specify the server is 8300, and then I'm inside the code called start listening. What does that mean to start listening? Just imagine you guys are client. I am the server. So I specify if you want to talk to me, Felix Wu, as your instructor, you have to use the port 8300. So I have something which is 8300 that I might receive requests from any of the students from EE1520. So listening means that, okay, I'm available. I actually listen to your request. So if your instructor is not here, that's the equivalent. I didn't run the server. So when you want to talk to 8300, it will say, hey, libcurl 007 error means that you cannot find your instructor. But when I listening means that I usually will idle. I'm just sitting here waiting for the question. By the way, I found that's pretty much happened very often in this class. I say, hey, do you have any question? Do you have any question? And you guys wait for chocolate. You guys didn't wait for the question. Okay. So which means that I actually turn on my port 8300 and you guys looking for a chocolate port, which is we mismatch. Okay. So it's my fault. I need to change my HTTP server to chocolate instead of 8300. But start listening. That's basically I'm idle. I'm waiting for you. If you don't send something, I'm just waiting here forever. Okay. So that's the port number, but the only tricky part is object 001. Okay, so let's look at the simple program for, let's actually talk about set label GPS. How do I implement the function? So first, you have to have this part of the code. Oh, you see that? I actually specify label GPS object 1001 is a null because later I will dynamically create and I have to include label GPS.h. Give me 1 minute, I will finish this. And I have my class server inherit from our server. Our server was defined in our server.h, which is generated code. I actually inherit from that code. And then I have two functions, set GPS label and dump to JSON. And they're both virtual functions. By the way, if you want to do remote procedure call, they have to be virtual function. Okay, they have to be. So that's why I have to teach you virtual function first before I can talk about remote procedure call. Okay, set GPS label. I have a 4 argument. And inside here, you can neglect this part, the timing part. And then I just check whether the object 001 is null, whether this object is a 0. If it's okay, then you see what I did. Object 101 label is equal to label. That's it. Okay, and then I return a result. That's everything we make this happen. Okay, so I'm going to stop here and I finish CPP 08. I'm going to talk about CPP 09 on Thursday. Okay. 那个